squared of theta equals 1. That's the Pythagorean theorem. If we solve for sine squared right there, we have to move the cosine squared. Sine squared of theta is equal to 1 minus cosine squared of theta. If we solve for the sine, you have to take the square root of the left side and the right side. That cancels with that. You have sine of theta is equal to plus or minus square root of 1 minus cosine squared of theta. So I'm going to, since I want every one of these factors or terms to be in cosines, I have to put in this form right here. Plus or minus square root of 1 minus cosine squared of theta times plus or minus square root of minus cosine squared of theta. Put this right there. All over cosine of theta plus that cosine theta right there. If I take this and multiply it, the square root cancels itself because the square root of the square becomes itself. The plus and minus also cancels. Positive times a positive is positive, negative, or negative times a negative is also positive. So you are going to end up with 1 minus cosine squared of theta over cosine of theta plus cosine of theta. There you have it. You could also do it, you can expand this out, but that should be good enough. Okay. I'm going to show you another way to do this problem. If I multiply sine times sine, that's the same thing as sine of theta times sine of theta over cosine of theta plus cosine of theta. This is the easier way, but I wanted to make sure that you guys know how to do it both ways, this way as well. We work out this term, we multiply straight across, you end up with sine squared of theta over cosine of theta plus cosine of theta. But we also know that sine squared is equal to, move this term over, 1 minus cosine squared over cosine theta plus cosine theta. So you notice that we do end up with the same exact answer. We approached it a little bit easier because I took the sine squared theta. Either way though, you should be able to do this because it might be on the test. Okay? Next problem. It says write cosecant of theta. Where's my homework problem? Write cosecant theta. It's supposed to be sine theta, cotangent theta. In terms of sine and cosine only. I miswrote the problem again. I should actually point to these as I'm writing them. Cosecant of theta times the sine of theta times cotangent of theta. And write in terms of sines and cosines only. Cosecant is 1 over sine of theta. The s in the middle, that should tell you that it's a sine, the reciprocal, times sine of theta over 1. That's the same thing as sine of theta. Cotangent is the reciprocal of the tangent. So it's going to be cosine of theta over the sine of theta. One of these is going to cancel out. So you are going to end up with just cosine of theta over sine of theta. It says write in terms of sines and cosines only, and there it is. The next problem, show 1 minus tangent quantity squared is equal to secant squared theta minus 2 tangent theta. Okay. We cannot, if you pick one of the sides, you want to manipulate the more difficult side to the easier side. Since these two both look like difficult sides, I can choose whatever I want, and I choose this one. The reason why I chose this one is because it's a little bit easier to manipulate. I'm going to distribute this out. 1 minus tangent of theta times 1 minus tangent theta becomes, excuse me, I don't need that. I'm going to fold this out. 1 times 1 is 1 minus tangent of theta minus tangent theta, so there's minus 2 tangent theta plus tangent squared of theta. Tangent theta excuse me, it's going to be minus right there. Okay? And I'm going to change all of these to sines and cosines. 1 minus 2 sine of theta over cosine of theta minus tangent squared is sine squared of theta over cosine squared of theta. And then I'm going to have to manipulate this somehow. I'm going to have it all in terms of sines and cosine. So here, I'm going to have to change it. I'm actually going to change one. Since the common denominator is cosine, it's going to be cosine squared of theta over cosine squared of theta. That's equal to 1. That's 1 right there. Minus 2 sine sine theta over cosine theta. We're missing a cosine theta factor for the LCD, least common denominator. So I'm going to multiply this by cosine theta, numerator and denominator, minus 2 sine of theta, cosine of theta, over cosine squared theta. Oh, shoot. Minus, and minus is plus. No, it is plus right here. It had to be plus. And then plus sine squared of theta over cosine squared of theta. We got under one common denominator, cosine squared theta. Numerator, we have cosine squared plus sine squared. We know that that's the Pythagorean theorem in trigonometric form. That's going to turn out 1. These two terms are going to turn out 1 minus 2 sine of theta, cosine of theta. Now we can break it up again into its partial fractions. That's going to be 1 over cosine squared theta minus 2 sine of theta, cosine of theta over cosine squared of theta. There's several ways you could have done this. I chose a little bit round method, but it should work. That turns out to be the secant squared of theta. That one of these cosine theta cancels. End with minus 2 sine of theta over cosine theta. What's the sine of theta over cosine theta? That's going to be the tangent of theta. Check. Secant squared of theta. Secant squared of theta minus 2 tangent theta should equal the right side. Okay? A little bit tricky on this one. Next one. Number 9. It says square root of x squared minus 16. You want to evaluate this expression given that x is equal to 4 secant theta. Well, what we're going to do is we're going to plug it right inside for the x. So that becomes square root of 4 secant of theta squared minus 16. We're going to replace it. Distribute this out. You don't get 4 secant squared, you get 16 secant squared of theta minus 16. That becomes square root of factoring out the 16. Secant squared theta minus 1. But we know certain things, some other things. I'm going to use another pen for this. We know that the tangent, let me see, sine squared plus cosine squared equals 1. I always like to derive these. So to get the secant squared, I'm going to go divide by cosine squared. Tangent squared plus 1 is equal to secant squared. Okay. So what do we do? Secant squared is equal to tangent squared plus 1. I'm going to put this right in here and replace it. Remember, this one equals that right there, tangent squared plus 1, tangent squared of theta plus 1, and then minus 1. That's secant squared. So that you can visualize that a little bit further. The 1's going to cancel. You end with square root of 16 times the square root of tangent squared of theta. Square root of 16 is 4, and the square and the square root cancel. And most of you should know that becomes the tangent of theta and the absolute value of that. There's a reason for this. I might get into a little bit later on, but for now, just remember that if you take the square root, it becomes the absolute value. Okay, a little bit tricky. Number 10, the last problem. you try to find the tangent of that angle. It terminates, theta terminates in quadrant 4, and it goes through the line y equals minus 3x. And it's better if you actually can visualize this, so I'm actually going to just kind of, whoops, excuse me, draw it out for you to see. Y equals minus 3x goes something like this. That's your y, that's your x. And all you have to do is, it terminates in quadrant 4, so pick a point, find a point anywhere in quadrant 4. This is quadrant 1, 2, 3, 4, so make sure you find a point in quadrant 4, okay? Quadrant 4, if I set x equal 1, in here, it's in quadrant 1 or 4 so far. If I let x equal 1, my y value is going to be negative 3. And that makes perfect sense. So pick that point, and of course from here you have to figure out what the r value is. X squared plus y squared is equal to r squared. And it's the easiest point that I picked for x equals 1. So 1 plus negative 3 squared is 9, is equal to r squared. R is equal to square root of 10. R, the radius, can never be negative. Okay, so you have to put positive square root of 10. I'm looking for the tangent of the angle. I know that the tangent of the angle is equal to y over x. Oh, I didn't even need r. Y value is going to be negative 3, x is 1, and the tangent of that angle is going to be negative 3. Okay. Last question that I'm going to be doing is the Pythagorean theorem, proving the Pythagorean theorem. We know that in a triangle, if it radiates out in quadrant 1, it doesn't matter if it's quadrant 2, 3, or 4. Here's theta, here's x, here's y, here's r, and the x value, and here's a point x comma y, of course. See how it's x direction and the y direction? So the Pythagorean theorem is x squared plus y squared is equal to r squared. And the first thing he's going to do is going to say, remember the Pythagorean theorem in trigonometric form, sine squared theta plus cosine squared theta equals 1. So this value right there, the r squared has to equal 1. So we divide it by r squared. On the left side, I'm going to use my nice thick pen. That's going to be x over r squared plus y over r quantity squared is equal to 1. X over r, the ratio of that is going to be cosine squared of theta. Y over r is sine squared of theta equals 1. I just proved the Pythagorean theorem in trigonometric form. It was a pretty simple proof. There's a little trick. That's the trick. The second part I'm going to do says sine squared of theta plus cosine squared of theta is equal to 1. I'm going to divide it by sine squared to the left side and the right side. Sine squared over sine squared is 1 plus cosine over sine. Cosine over sine is going to be cotangent squared theta. And what's 1 over sine is the cosecant. So it's going to be cosecant squared theta. That's the second form of the trigonometric form. I hate memorizing this, so I derive it every single time. The next one, sine squared plus cosine squared is equal to 1 again. Instead of dividing by sine squared, we're going to divide by cosine squared. Sine squared over cosine squared. Sine over cosine is tangent squared of theta. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared of theta. So I don't like to memorize this, so I have it derived every single time from the Pythagorean theorem. Good luck, guys. Thanks.